Hey YouTube, what's going on? I'm Rocket, and today we'll be doing Book from HackTheBox, which is rated as a medium level difficulty machine. However, I found it to be more on the harder end of the spectrum, mostly because during every step of the enumeration phase, you really had to think about what the underlying technologies were doing rather than just simply brute force and try every technique in your pen testing checklist. So, without further ado, let's get right to it. So as always, we're going to want to start out with an nmap scan where we enumerate all TCP ports. We can do that with sudo nmap -p- and -oa to output all formats. Nmap, we'll call it all TCP. The IP address for book is 10.10.10.176. I've already ran this command, so let's check out the output below. So it looks like we have port 22, which is SSH, and port 80 open. Let's go enumerate those for the service version. So we'll do that with a sudo nmap -p80 for the web and 22 for SSH. And we'll provide the -sc flag to run all nmat default scripts and -sv to enumerate for all service versions. And we'll output this to nmap all TCP version. Again, the IP address 10.10.10.176. I've also already ran this command, so let's check out the output below again. All TCP version.nmap. So it looks like we have an Ubuntu server on our hands and an Apache HTTPD. So let's go check out the web service right here. So first we'll run Firefox in private mode. Firefox /private. I run it in private mode because I don't want to provide any spoilers with autocompletion while I make this video. And also we want to have burp running in the background since it is a web application and burp will do some passive crawling for us. So let's fire this up. Next, start burp. And let's go to proxy, intercept this off. Let's go to 10.10.10.176. And it asks us to sign in. So we could try some SQL injection right here. Before that, let's turn the burp intercept on. So I guess it did autocomplete. Just ignore that. So we'll just try like something like admin@example.com. And we'll put a password, we'll put double quote or space 1 = 1 semicolon and then hashtag. Let's sign in, catch it with burp. Oh, my bad. It looks like Firefox in private mode actually doesn't have the Foxy proxy extension right here. That's unfortunate. Maybe I'll fix that next time. So sorry about that. Let's open up Firefox the regular way then. Try to do something new, didn't work. So let's go back here. And now we have our intercept on, cool. All right, let's try it again. So intercept is on, we'll go admin, and there is a client validation here, which is encouraging us that you do need a valid email address. So you probably predict the form of the admin login potentially. So we go admin@example.com. And then password, do the same thing, double quote, space, or space 1 = 1 semicolon, and then hashtag. So make sure we have intercept is on, and then we'll just go ahead and sign in. All right, so just so this looks a bit prettier, Control-Shift-U to URL undecode it, and we can see this is just kind of like a typical SQL injection bypass that we can try. We could try a double quote, we could try a single quote, we could try the hashtag, we could do -- and then another dash. I'm just gonna try this for now. Of course, you're going to want to re-URL encode it with Control-U. So I'm actually going to throw this to the repeater so we can try multiple SQL injections. Go ahead and forward this, and it says nope. So SQL injection failed right there. Let's give it another attempt before we give up on SQL injections. Let's try a single quote instead. And let's go send. And it says nope again. So I'm going to stop right here for SQL injection. Well, how about we just go ahead and sign up? So I'm gonna go create myself an account, just so I can get more access to go ahead and pen test. So my name is going to be Rocket, and my email will be rocket@example.com, and we'll provide a password. Password will just be like password. We'll go ahead and turn the intercept back on so we can throw this into the repeater and create new accounts or more accounts in case we need. Go ahead and sign up. So we've intercepted it, hit Control-R to send to the repeater, and I'm just going to let this pass through because I just want to sign up. And it looks like we got redirected, so let's just turn intercept off for now. Looks like we got redirected back to the login page. Let's try logging in. Rocket@example.com. Password is password. Intercept on because I want to see how this works. Go ahead and sign in. Looks good to me. I'm actually gonna throw this to repeater. And also, to stay organized, how about we go ahead and label these as well? So this one is, we'll just call this, actually we can get rid of this one. We'll go here, we'll just call this sign up. And we'll call this login. Cool. And we'll go to proxy. I think I already forwarded this to the repeater, which I did. And we'll just go ahead and forward this. Turn intercept off. And it looks like we have logged in. So we have awesome collections. Thanks for being a member of our site. Keep reading, and if you have awesome collections, you can contribute too. How wonderful. So let's go ahead and go view our profile. So our name is Rocket, rocketexample.com, user. We could also go in burp and see what burp has passively spidered, which is one of the reasons why I really like having burp running in the background. So burp already caught a bunch of endpoints right here, but sometimes there are also hidden endpoints which I like to discover while I'm doing some recon like this. So always do recon in the background, even when you're doing web. And we do notice that this is a PHP application. So what we're going to do is there's going to be more surface to attack if you're logged in. So in this case, we're going to need our cookie PHP session ID, because I'm going to go run gobuster and discover some hidden content here while I go and pen test this web app. So always multitasking, always multitasking. So let's go ahead and create a directory called web, which is going to hold all our web related tasks. And I'm going to create a subdirectory called discovery. So I'll go into discovery. Actually, we'll call it gobuster. Discovery, we'll call it gobuster. So we'll go to gobuster and we'll run gobuster dir. To enter directory brute forcing mode, we'll provide a word list. I like to use the user share seclists one. If you don't have seclists already, I think it comes installed on Kali by default. If it doesn't, you can always do something like sudo apt install seclists, and it should just install it for you. And we'll go to something like discovery, go to web content, display all 128 possibilities, and my favorite list for this is going to be raft large words.txt. So we'll run raft large words.txt. And as I mentioned earlier, this is a PHP application. So we have a lot of these files that end in .php. So probably -x, we'll call it. Basically, we're going to append a .php extension to every entry in this word list. So .php, provide the URL, which is http 10.10.10.176, and last but not least, we need to provide the cookie with the -b flag, so we don't get redirected to the login page after every failed attempt, or even every attempt in general. So do this, and we're also going to keep an output because we might want to gobuster recursively into directories that are discovered. And this is just to stay organized. So call this logged. Well, actually, we'll call this user raft large words. Actually, let me move my face here. Raft large words big php.out. So let's invalid status code blacklist. Oh, maybe it wasn't the -b flag. Maybe I was thinking of wfuzz right there. Let's go check out the flags again. So gobuster dir -h, and we should. Oh, it's a -c. So -c is for cookie. My bad. So -c. There we go. So let's just let that run in the background. Right off the bat, we do see a /admin directory, which clearly wasn't available right here. So we're actually going to go ahead and add that to our list right here in our URLs. So we'll take this, go pop over to admin. And wow, we have just found a new admin sign-in. So we could also try our SQL injection right here. We could try something like, actually, we'll go here later. I want to show you something first. So if you keep clicking around here, and apparently I got redirected out, or my cookie session expired. Let's log back in. We'll do rocket@example.com. Password is password. Log in. So if we go to books, we'll see a bunch of books. Not too interesting. You could try downloading the PDFs and try doing some steganography on there, but I've already tried that. For the sake of the video, there is nothing there. So go to collections, we can look at this later. And if you go to contact us, which is relevant to figuring out usernames, we'll notice that we can contact the administrator by possibly sending a message to admin@book.htb. So for our admin panel, we can already try the SQL injection by possibly finding the correct username. So we have the correct username, most likely this is admin@book.htb. We can try doing a SQL injection here with the same technique we tried earlier. So a double quote or 1 = 1, semicolon, and hashtag. This throws to the repeater. So first we need to intercept this HTTP request by turning intercept on. Go ahead and sign in. We'll go send this to repeater with Control R. I'm actually going to keep this right here, but I'm going to call this admin login to stay organized. So admin login. And we can go ahead and see the syntax here, just kind of like before. Control-Shift-U to DURL encode. That's the same SQL injection payload we tried to bypass the first login, but this time we're trying for admin with the right username. So let's go ahead and forward this. And it says nope. So let's give that another shot with a single quote instead. So let's go to admin login, possibly URL undecode this, Control-Shift-U. We'll use a single quote instead of a double one. And then highlight, Control-U to URL encode again, go send, and it gives us nope again. So no SQL injection there. That's unfortunate. So from here we can try doing a cross-site scripting attack, because we noticed that we have the admin user here and we can potentially go ahead and steal their cookie. So let's try going to my favorite site for cross-site scripting payloads, and that is this one right here. So you can go to Google and search for payloads, all the things, cross-site scripting injection, and we should be able to find one that will help us go ahead and steal a cookie. So scrolling down, this is the one we want, daily grabber for cross-site scripting. We're just going to go ahead and let's go and take let's take this one right here with where it just creates a new image. So let's go ahead and get that. Let's go back to our Kali machine, and I'm going to go ahead and make a new directory called exploit. So go to exploit directory and we'll call this xss.html. So set paste, dump what we just copied, and instead of localhost, we're going to try this on our HackTheBox IP address, which is 10.10.14.15. We're going to listen on port 8000 because we're going to run Python HTTP server to go ahead and do this and steal the cookie. And give this a save. And before running it on the remote machine, let's try it locally first. So before you proceed, make sure that you have the intercept off on Burp Suite, because when we go ahead and run Firefox xss.html, we are going to spawn a new tab in our current browser window. Let's go ahead and do that. Actually, my bad. I forgot to spin up the HTTP server. So Python 3-m http.server, and let's go and go Firefox payload or xss.html. So that did something, and it looks like our payload works. We got a HTTP request. Of course, the cookie we don't get any cookie right here because there is no cookie really to begin with, but we know that the web browser calls back to us. So if it fails, we can tweak the payload afterwards. Anyways, so let's go ahead and copy this. Let's go get this right here. Control-Shift-C to copy, move back to Burp Suite. Actually, move to our web browser. And we'll go ahead and paste this. So before we send, we are going to want to catch this by setting intercept on. Go ahead and hit send. So here's the message. I'm going to Control-R this to send it to repeater. I'm going to call this contact XSS. And let's just go ahead and forward this. And your message has sent. So make sure that you have your listener up here ready to catch it. So I'm just going to call this XSS listener. Close this for now. Control-D to close that, and we'll just let that sit for a bit. So we're basically doing just waiting around to hopefully get something. We may never get it. So anyways, now that we've kind of tested that, should turn intercept off, first of all, so we get redirected to library. And next, we can go ahead and check books. We could go ahead and click here, download the PDF. I think I mentioned before, there is already nothing here, so I'm not going to bother with this. And we could go ahead and try to submit a book. So we could try doing a, trying to upload a PHP file and try to exploit LFI right here. But I already know for a fact that that's not a thing. So for the sake of this video, we're going to take a shortcut right there and just call this a no-go for that. Anyways, moving forward, let's go view our profile. Our username is displayed here. So my name is Rocket right here, but maybe let's try some SQL injection like quote or 1 equals 1 semicolon hashtag. Go ahead and updated. And interestingly enough, we get some data repeated right here. So that's odd. You might even, like, if this weren't HackTheBox but over like a real world site, you might even want to like try some cross-site scripting like script and then just do like a little alert just to test it. Like alert, like pwned, and just go ahead and try to update this. It was updated. So here it looks like our input got truncated. So let's see how many characters we have here. So let's copy this and let's go echo -n and then single quotes, so no meta characters get escaped. We're also using a -n flag so we don't count the new line at the end of our echo when we pipe it through wc-c to count all the characters in here. So in this case, we have 10 characters, which means that our input got truncated down to 10. So what if we tried doing something like 1, 2, 3, 4, 5 followed by, say, 5 more spaces, so 1, 2, 3, 4, 5, and then some random character like 9. And then let's go update. And it looks like we also have 5 more spaces right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And okay, it looks like the name is fine with that, but what if we thought about some of the other fields, like email, for example? So in this case, my email is rocket@example.com. So I wonder what the truncation limit is for email. So if we copy this and we do an echo-n, same thing, count how many characters are in this email, it is 17. And if we also did something like admin at book.htb, that is 15 characters, which also counts. So what if we, actually it's 14 because it's one I. So the question is, what if we tried signing up with a username with more than 17 characters? What is the limit there? So I'm gonna try 50 because I know that's pretty high up. So let's go, and because we kept our tabs and our repeater, we're gonna save some time this way, which is why I like to do this in my workflow. So we're gonna go ahead and sign up. We're gonna create a new account. I guess get rid of this ugly URL encoding, and we're gonna go ahead and call this. We know that rocket@example.com is 17 characters. So if we go ahead and do something like create some random stuff with Python, we'll do something like print. We'll just put a bunch of A's. We'll do A times 50 minus length of, what is it, at book.htb. Is this invalid syntax? I'm trying to get adventures right here. What is this? Print. Oh, because it's Python 3, of course, you need brackets. Okay. Print 50 A's. Oh, yes. This is how many A's we want. So it's a bit confusing. So this should be the amount of A's before book.htb we get. So let's try this. We know book.htb is 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. So this should be equivalent to A times 41 for when the math gets really complicated, I guess. So it's the same thing, but I like the syntax more. So let's go ahead and try creating a new user called bunch of A's at book.htb, and we'll just call this name something like admin, just in case the admin name is checked as well. So let's see what happens when we do something crazy like this. Go send, and looks like it worked. Did it work? I'm just going to copy this. follow redirection. So, oh wait, no, that didn't work because we need to re-URL encode this. The @ sign is, I don't think it's a good character in URL encoding. Let's go send. Okay, found. Follow redirection. And okay. We got redirected back to home. Oh, wait a sec. Well, let me get rid of this cookie first. Because if it sees our cookie, it's probably going to think that we're always logged in. So let's get rid of that first. Let's go send. Follow redirection. It wants us to. Is back this login page? I think it is, because it doesn't say, yeah, please fill in the form field. Should not be more than 10 characters. Okay, so let's go ahead and try and log in with this. I'll paste. Maybe URL encode. Go ahead and send. Found, follow redirection. Okay. So apparently oh, same mistake as before, my bad. Let's get rid of that cookie. Send, it says nope. So that's interesting. Did not let us log in with something with about 50 characters. Speaking of which, I wonder what happens if we go ahead and try and overwrite the admin. So maybe let's just try changing the admin's password or creating a second admin user instead. Let's go ahead and do that. And it says user exists, so that's no good right there. All right, back to our original plan. Got a little sidetracked there. So 50 characters clearly did not work. Let's try cutting that in half. So instead of 50, let's try something like 25. Do it in half. So we'll try this many A's and try to log in with book.htb this way. See if we have any luck right here. So copy this, Control C, go ahead and send. Okay. Now let's try and log in with this. So copy this, make sure we don't have any cookies here. Go ahead and send. It says nope. Okay. So this is 25 characters. Well, it's actually not 25 characters, but if we do something like this. Actually, it is 25 characters. I lied. So, okay, maybe let's try 20. So let's subtract 5 from this. 1, 2, 3, 4, 5. See if this works. So this time we have 20 characters. And just to verify that, we have 20. So let's go back and sign up. Let's go ahead and dump this. Maybe URL encoded as well, just to be safe. Control U. Go to send. All right, now let's try to log in with this. So do this, Control V, highlight again, Control U, go ahead and send. And we get a login. So follow redirection, found, follow redirection, and looks like it should work. Welcome back. Hey buddy, sign up. Struggling to read that super quickly there, so actually let's just go log out here. And we'll just go ahead and log in this way. Password, sign in. So, okay, so it says sign in as admin, and this is our email. Definitely not the, Definitely not the actual login that we're looking for, but what if we try going to admin, and then, yeah, nothing there, okay. So, in the meantime, actually no. So, all right. So we notice here we have 20 characters because this is a at book.htb. So what happens if we did a little bit more, because it may not be 20, it may be, maybe let's try 21. So we'll try signing up with this one right here. Control Shift C. And then we'll just sign up with this one right here. It has one more character, so we'll just go. Well, actually, let's copy paste just to be consistent with what we've been doing this whole time. So Control V, Control U, double check this. You really don't want to mess up your payloads. Okay, that looks correct. And let's go and send this. So found, go to login. Let's go back a couple and let's try logging in with this. Control V, and then URL encode, password, send, and it says nope. So we have identified that the character limit is indeed 20 characters for the email. And now, what if we tried doing something like creating a second admin user? So instead of doing, like, this is the target that we want. So we didn't know for a fact that this here is 14 characters, but if we add a few more spaces, so it's 14, 15, 16, 17, 18, 19, 20, and then add another character right here, we're going to exceed the limit. So it's going to be 21 characters. And what's going to happen is, hopefully, the truncation here, when we go render, when we go try to go to this admin panel right here, the application will basically read the data from the database without white spaces, hopefully. So, because this right here, let's just see if we get any white spaces, because that will really tell us if we've actually created a second admin account. So let's go copy this just to be sure. Give this Control-Shift-C. Go to sign up. And we're going to paste this, Control-V. And make sure you're all encoded, because white space will definitely break it right here. We're going to keep name admin to be consistent, just in case the application also checks for the name for whatever reason. And we're going to change the password to set the password to password. So this is going to go ahead and insert a new row. And hopefully the new row will just be admin at book.htb. So let's go ahead and send this. So that seemed to work. Cool. Let's go ahead and copy this right here and see if we can't log in. All right, let's go here, Control V, and go send, and it says nope. So interesting. But I wonder what happens if we just go and try to log in with admin at book.htb. So this actually worked. So it looks like something got, when we inserted when we created this right here, what happens is this actually got truncated, like all the white spaces got cut down to admin.htb. And this one just pretty much got dropped because the email field in the database schema is 20 characters. So when you truncate MySQL, or when you truncate strings in general, the default behavior is to cut white spaces. So we pretty much just ended up adding a second admin user, bypassing the application's business logic. And if we go, and hence we were able to log in with this as password. So let's go ahead and copy this cookie right here, and we're going to put it into our browser and see what happens. Let's go here, go to inspect element, storage, and we're going to go and paste this, maybe without the PHP /id. Hit enter, and let's go ahead and refresh the page and see what we are. So we have book.htb. Our role is still user, which is kind of interesting. But if we go ahead and look how many inspect element right here, I don't see any extra padding and spaces, unlike the name from earlier when we were testing with the 1, 2, 3, 4, 5, which is definitely interesting. So this looks very promising. Looks like our email is now admin at book.htb, and if this email is used for authenticating, like by validating into the admin panel, then we might just be admin. So let's go, since we have our cookie load into our browser, let's try to refresh this admin panel. And let's try admin at book.htb, and its password is password. Go to sign in. Nope. So this might have thrown you into a loop. I think there is a timer on this box that goes and resets the password. So if we were to just go and do this again, it says nope. So if you find that if you try to log in a second time, bear in mind this is HackTheBox and multiple people are trying to get in. So if there weren't a timer, it probably wouldn't be fair for some of the other players, or they might get an easy bypass just by you know, typing password for admin@book.htb. So always make sure to re-go through the process of kind of like creating the account, or, well, in this case, it is creating the account. And just go create again and go through the process, but do it faster. So we're gonna do it fast this time. So we'll say, do this, log in, send, okay, copy the cookie, go quickly to our browser, go to inspect element, storage, hurry up and paste this, Control V, hit enter. Actually, that wasn't necessary. We'd have to go to admin@book.htb and go password. So sign in. And okay, we got in. We were fast enough. Usually you have about a 1 minute buffer time on these machines, so keep that in mind. Gotta be fast. Okay, so we're finally into the admin panel. Let's we've found some new space to navigate here. Of course, we're going to go ahead and gobuster this, just like we did before. So apparently here we had some data, but we're gonna keep that for later. It wasn't really useful, other than finding the admin panel. So I'm gonna call this user and make a directory called admin. Let's move the user. Actually, this isn't necessary. Let's remove admin and user. So we'll just run a gobuster again, gobuster dir w. And instead of this as our cookie, we have, well, this here is now our new cookie. And this time we're actually going to target the different path now that we actually have an admin cookie. So go admin. Oh, and just for those of you who are curious, the cross-site scripting attack that we tried earlier never worked. So, but yeah, it was worth trying. So go to admin and let's see if we can find discover any more PHP files under admin. So instead of calling it user raft, we'll just call this admin raft. Go run and let this run in the background. So anyways, let's go to users. Here we can see all of our mistakes and attempts that we've made. Interesting how we have boo. Looks like something got truncated here. Anyways, go to messages. Hey, there's our cross-site scripting attempt, which is not very cross-site scripty because our browser never really sent a request back here. And I know for a fact that my proxy is also off here. So, interesting. Go to feedback. I guess you could try, I mean, at this point we're admin, so cross-site scripting doesn't really matter anymore, so we're not going to bother with that. We go to collections and we're like, there's some users and collections.pdf. So let's try exporting the users. Click here. And let's go ahead and open this file. It's some default PDF reader. And hey, it looks like our data is being rendered, which is quite interesting. So we have the name and the email being rendered as an HTML table, which is interesting. So noticing the format right here kind of rings a bell where there is some server-side technology that is in fact generating this. And if the server-side technology is processing data to generate HTML, then we could probably assume that it's processing JavaScript. So if there's JavaScript, like script tags in here, we might just be able to dynamically generate HTML. But even more than that, we might just have arbitrary JavaScript code execution on the server. So we could try a cross-site scripting attack here. Unfortunately, that's not really viable due to the schema restrictions of the name and the email. So we've discovered that the name is limited to 10 characters and the email is limited to 20, which is barely enough to perform a viable cross-site scripting attack that is actually useful. If you guys know how to do viable cross-site scripting attacks within like at least 20 characters in order to like steal stuff, please let me know in the comments below. I'd be very interested. So anyways, that's kind of moot. Let's try clicking on collections. See if there's anything there. So let's go open this, go okay. And here we have titles, corpse flower, queen of the night, chocolate cosmos, lady slipper, and this is export the collections. So if we remember back here, we had a collections tab. So apparently we were able to submit books, and if we hover over books, these here were the collections from earlier. So Corpse Flower, Queen of the Night, Chocolate Cosmos, and Lady's Slipper, which happen to be all rendered right here with their link. So the question is, can users go ahead and manipulate the data? So let's say if the title were a cross-site scripting attack. I'm not quite sure what the input limit is there, because it might be a different database table altogether. So we might be able to do something right there. And how about we give that a shot? So let's try doing something like upload our own collection. We'll give it a book title. I'm actually going to go and change this in the repeater. So I'm just going to call this Rocket Book. I'm going to call it the author's Rocket. And we'll just upload some random file. Let's go to home, maybe, where is it? HTTP, boxes. Let's go to, actually no, go to write-ups, boxes, go to book, web, exploit, whatever, let's just upload a cross-site scripting thing. Let's go open. And we are going to go ahead and intercept this with burp, so intercept is on. Go ahead and hit upload. And now we get something like this. So definitely send this to the repeater of Control R. And we're going to name this, what is it? Book submission. So we'll call this book submission. Cool. So I'm actually going to get rid of this thing right here because I don't think the content actually gets rendered. The content occurs when you go ahead and click the link. So the content that actually is going to get rendered is title and author, which are both good candidates for cross-site scripting. So let's just try the title first. So let's just do test. And for here, we'll do something like, actually, speaking of which, we might as well just go ahead and take our cross-site scripting payload from earlier, just to like test that cross-site scripting actually works. So vim cross-site scripting.html. Let's go ahead and try something like this. This is probably not going to be a cookie, but I just want to see if we get a hit back from it. So hopefully the server will process this as HTML, interpret the script, and execute arbitrary JavaScript on the server side, and hit us. So let's go ahead and send this. So thanks for submission. We evaluate and update the list. Cool. Okay, so let's go back to here. Let's go back to the admin panel, and let's hit collections. So let's go export it. And no idea if we got a hit or not. Let's go. Looks like it got stuck. Or maybe I just have burp intercept on. Yeah, I do that all the time. Let's go ahead and drop this right here. And intercept is off. So hopefully that did something. Open with. Well, actually, before we open it with, make sure we actually got something. And it looks like our payload got executed. So we noticed that we have the book IP address right here saying get cookie. And let's see what happens when we open it up. Probably a bunch of garbage, but that's fine. We know that our cross-site scripting payload executed. And this is actually how you test for a blind cross-site scripting. So clearly there's nothing there. Author's Rocket, like we put. So that is good news. Now we need to actually use our cross-site scripting to exfiltrate data from the server, because the JavaScript is executing on the server remotely, which means that we should be able to access its file system. So let's do some research on that. Go back to Google right here. So we look for something like server-side XSS download file, because that's what we want. And hey, apparently we have something in Hacktricks right here, which I'm going to provide this link in the video description below. It's called server-side XSS dynamic PDF. So apparently if a web page is creating a PDF using user control input, you can trick the bot into creating the PDF into executing arbitrary JavaScript code, which is actually what is happening in this scenario right here. Because if the PDF creator bot finds some kind of HTML tags, it's going to interpret them, and you can abuse this behavior to cause a server-side cross-site scripting. So stuff I explained earlier, but if you want to learn more on it, you can check out this link right here. Anyways, we want to go and exfiltrate data. So actually, the most efficient way to do this is by loading an external script. So notice that on our machine right here, we went ahead and tried to get the book machine to go and download a file from our machine, but we could also load scripts externally, so which makes testing a lot easier. So let's go back to here. So read a local file. And this is probably what we want right here. So script x equals new XML HTTP request. By the way, this is how you send HTTP requests from your browser. So as soon as x loads, it's going to go and base 64 this response text. So it's going to open file etc password, send, and as soon as it loads the results right here, it's going to write them to screen. So let's go ahead and copy this, and well, actually first we need something to load an external script for us. So actually let's copy this first. So let's go to right screen, close this, and we're actually going to call this loader. So loader.html, because this is what we're going to slip into our burp suite request. So set paste, Control-Shift-V. So we are not attacker.com. We don't have a domain. We have an IP. So 10.10.14.15, port 8000. Instead of calling it mysql.js, we'll just call it exploit. And we have some source that probably doesn't exist. I'm going to change this just in case someone else on HackTheBox might have been using this. So let's call this rocket, like that. On error, document.write script source. We'll change attacker.com to 10.10.14.15, port 8000, exploit.js. And we should just be able to load this. Okay, so let's check if this works. So in order to check that this worked, we should be able to give this a save, and we're going to make something very simple just to verify that this worked. So we'll call this, of course, exploit.js. And our JavaScript code will just be something like document.write, something like rocket. Our rocket was here. Make sure the quoting isn't too weird, so loader.html, single quote should be good, I guess. So basically, let's open up the loader again. We're gonna copy this, so set no new, so we get rid of the numbers, copy all this right here, Control-Shift-C, go back to burp suite, and go to our repeater tab. Instead of doing this, we're going to use our little loader, and hopefully this will work. I'm probably going to get rid of new lines because I always fear that new lines break stuff. I don't know why, just do. So get rid of that. Make sure you have your web server listening, which we do right here. I'm actually going to delimit this for a couple spaces. Close this. And what's going to happen is we're going to send this, go send. And now when we go and export the collections, that JavaScript code should execute by downloading it from our server, and then it should render it. So let's go and open this. So we have something like rocket was here, and we did indeed download the JavaScript code. So it looks like our loader worked. And it looks like it also executed it, because now we have something like rocket was here. Point is, we grabbed the exploit code and we executed it, which should be good enough for us to go ahead and start exfiltrating some files. So we're actually going to go and change our exploit to this right here. So copy this, go to the right screen, and let's go and edit our exploit code right here. So set paste, Control-Shift-V, and we can probably get rid of the script because it is a JavaScript file. And I'm actually going to make this a bit prettier. Well, actually, no, let's keep this. Okay, so we're just going to get etc password and see what happens. So let's go and export this again. Let's go export. And nothing. And that's probably because our payload has been cleaned up somehow. There's probably some cron job like before. So if we go and open this, we're gonna notice that, yeah, our collection isn't there. So to fix that, all you have to do is go back to Burp Suite and send again. So send, we'll send the loader again. Go ahead, go back to collections, do this, should load our code. There it is. And let's go ahead and open this. Go open. Okay. And hey, look at that. That looks like a base64 encode etc passwd. So let's Control-C this. And apparently I can't go out here, but we'll try to fix that later. So close this. Let's go echo-n, take what we got, and then base64 decode. 64-d and then xxd, just in case it is binary data. To me, this looks like an etc password file, but we didn't get everything that was there. So we need a way to actually read this content right here, because this is not doing us any good. So I tried some tools here like PDF to text. The PDF to text only renders what it sees, so it is clearly going off the screen. And when I ran through this box, I actually changed the font size to be something smaller, and I wrapped this here in a div. So we're gonna wrap this in div because it is HTML after all, and we're going to word wrap. So you can think of a div in HTML as like this little block, but instead of like overflowing out of the div, we're actually going to like wrap around. So we end up fitting in the page. And we could also try reducing the font size so we could fit more text on the screen, because when we copy to our clipboard with Control-A, it really doesn't matter. So let's do some styling right here. I guess you'd call it some web styling. So we can go and edit our exploit.js. So we're gonna make this a bit prettier. So document onload, and I'm gonna go create a new div. So we'll say something like my div equals, and then go div id equals, let's say rocket div. And we're also going to write the B2A response.text in here. And then we need to close the div, of course. So close the div, /div, semicolon. And notice we're doing this all in the onload function because we only want this action to happen when the page loads, which is going to hold the contents to the etc passwd, which hence the this.response text. So I of course want to write my div to the document, and then we want to do document.get element by id so we can get the element. So in this case, our ID is rocket div. Excuse my poor coding right here. It's just a proof of concept, so it doesn't really matter. So we'll take this, maybe double quotes. Whatever, single quotes, fine. And then we can say dot, and I think the CSS element was, let me go back and see if I can recall this. So JavaScript 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 style word wrap. That's what I want to do right here. It's like style.word wrap equals break word. So you can go try it yourself, try it, and we're going to get the words to wrap. So we want to go get style.word wrap right here. So notice document.get element ID. Let's copy this right here. Go back to our Kali machine. Control-Shift-V to paste. So we have the word wrap. I wonder if we can change the font size now. So go back to our browser, do a little more research right here. So instead of word wrap, we want font size. Font size property. Can we? Okay, well, we might just be able to do something like, if we copy this line, style.word wrap, we'll say style.font size. Maybe we'll try XX small because we want to jam as much text as we can. Okay, go back to the right screen. Well, actually no, I think this should be enough. I think it should be enough. Let's give this a shot. See what happens. All right, so let's go to burp. Let's send this again because the server probably cleaned it up. Send, go back to Firefox, export to collections. Let's go to download our JavaScript for the third time. Go ahead and open this file. And this looks a bit more promising. We see a bit more data right here. So this might be the entire etc pass WD. So let's Control A, Control C, and see if this base64 is not broken. So Control Z, send it into the background, do an echo -n. Maybe create a temporary file. Set paste, Control-Shift-V, and we're gonna replace all new lines with nothing. So Control replace new lines with a bunch of nothing, do a global replace. Cool, let's call this test.b64, quit out of it. Base64 decode test xxd just in case it broke everything. And okay, that looks fine. Maybe just do that. Hey, that looks good. Looks good to me. Is it really okay though? I think it is. Cool. There is one last thing I want to verify though, and I think it's just because, well, okay, no, I think it's fine. So this looks kind of route, I think. We do notice that if we look carefully at the etc pass WD file, we can figure out which users have an interactive login. So let's call this pass WD. So if we grep for anything that has like bin bash in it, we'll notice that we have two users that have can get a interactive login, and that is root and reader. So we don't know reader's password. We could try to go and go to the web application and see if there's any password reuse, but the simplest way is probably just to go and grab a private SSH key and use that to log in. And if, for those of you who are familiar with Linux, the path to getting the private key is standard and well defined. So what we can try doing is, in our exploit code, we could try getting, instead of the etc pass WD file, actually let me format this a bit better. We could go ahead and get the home reader.ssh IDRSA file. And the IDRSA file is the standard name for a private key. Of course, you can name it to something else, but by default, this is what it is. And this is what most people call it. So let's see if we can go ahead and steal that. So let's go ahead and put some spaces right here, and let's fire off our exploit again. So we'll go here, go to send, go back to Firefox, trigger the export. Our code got executed. Let's open the file. And this looks promising. We get a result here. So let's Control A, Control C. And here we're going to go ahead and edit a file again. So we'll just call this idrsa.b64. Set paste so we can paste our buffer. Control-Shift-V. set no paste, and let's format this, get rid of all new lines, shift Z, base 64D IDRSA, base 64 XXD. That looks like that definitely looks like a private key to me. So let's go ahead and dump this to, let's call this reader.idRSA, because we are trying to get the reader user's IDRSA. I didn't try to go get the root users. You probably want to, because the web application probably doesn't have permissions to go and do that, or sorry, not the web application, but the file, the software that is executing our JavaScript. So I'll show that to you after this. So base 64 here, I'll do that, and we'll check out reader.idRSA, and looks like we have a private key thing, which looks good. So if we try to SSH as reader, SSH reader at, well, call it 10.10.10.176, and we need to provide the private key. In this case, it is reader.idRSA. We have bad permissions on the file, so we do need to chmod 600. Like, before we do that, if you take a look at the private key file right here, notice that it is a world and group readable. SSH won't let you use it if it has these permissions, because it wants to encourage you to secure it. So you can just go ahead and chmod 600 reader IDRSA. And now when you take a look at it, you'll notice that only the user can read and write to it. So now it's secured. And you can do, again, SSH, and we're in. Cool. So that is the user own. There's the user flag right there. But just for those who are curious, what if we try getting the root IDRSA? Well, first off, they might not even have one, but let's see what happens. So if we go and edit our exploit.js code again, we'll try to access root /root. Oops. Root. SSH IDRSA. Probably doesn't exist, but let's give it a shot. Let's go back to burp, go to send, go to Firefox, export this, and see what happens. Probably some weird stuff. And I think we got it. But let's see what happens when we open it. Okay. A bunch of nothing. Okay, so it didn't work as expected. So that's what happens if you try to steal root's IDRSA key, because it might not even have one. You probably have more likely you have a permission denied. Anyways, cool. So on to owning root. Before moving forward, I like to go ahead and create a directory called loot, where I store all my loot, of course. So we'll copy web exploit reader.idRSA here. Actually, we'll move it to loot. Go to loot. We'll SSH back in. And we can stop this thing right here, because now we actually have a login. So probably going to rename this window to SSH. Oh, our gobuster finished. That's fine. We don't need this window anymore. So /l. Looks like we have some weird script, LSC, probably some enumeration script left behind by the author. We're not going to bother with that. And we have backups. So ls-l backups. We have access log and access log.1. So let's take a look at this. So ls backups access.log.1. Interesting. So it looks like there's like some sort of a log backing up going on here. Let's see if we are part of any special group with ID. We're not. We're just a reader group. Can we run sudo l? We need a password. We don't have a password. Maybe we can try something like reader. And we get a bunch of nothing. So Control C. All right. So at this point, I'm going to go ahead and run some auto-enumeration tools. Control L. Let's go to tools, priv-esc, go to privilege escalation awesome suite. I like to use linpeas right here. So get pull just to make sure we're up to date. In this case, there's probably some new privilege escalation tricks. that we got. And if we go to linpeas, we're going to spin up another HTTP server here so we can download this and execute it. So http.server, go ahead and run curl http 10.10.14.15 port 8000. I can type. It's called linpeas.sh. Pipe it through bash. Let's go ahead and auto-enumerate this way. So this is going to take a while to run, so we probably start checking out what we've already discovered. So the pseudo version might look a little outdated. We'll keep that in mind. We also happen to app armor is enabled, so that's interesting. Get some useful software. We have a compiler toolchain. We also have netcat that we get in curl. Definitely have the compilers installed. Let's check out the processes. So Apache, that makes sense. It's HD. Going down, we have cron. We have this weird thing right here, which is definitely not standard. Root reset.sh. So that's definitely odd. I have no idea why that's resetting. We could try reading it in case the permissions are really weak on it. So we'll keep a note for that. So I'm going to create call this notes.txt. We'll just put that right there. So maybe we'll call this suspicious files. Something like that. Okay, yeah, save. Go back to our SSH session. We got cron. And let's keep going down. So nothing too interesting in binary process permissions. Looks standard to me. Cron daily. Apache 2 could be interesting. App armor is outdated. It's probably a minor thing. Won't worry about it too much. And this looks very interesting because book.timer just passed 35 seconds ago, and book.timer is definitely not standard. So we're gonna want to go and investigate this for sure. So book.timer, call this suspicious timers services. Okay. So go back to SSH. This is probably where linpeas kind of froze on me, so let's go and hit Q. Okay, it finished. All right, let's go back up. Going up. Okay. So this here is all standard on Ubuntu. It's just the snap daemon. Nothing there. We have a MySQL database, which we could go and exfiltrate. So I'm gonna add this to my notes. So MySQL database might find goodies locally. Let's go down a bit. I guess we have an ephemeral port here, but that doesn't. I'm not too concerned about that. We're not part of any interesting groups. We can't do sudo l because we don't have the password, but we might be able to find the password by finding a password reuse vulnerability by searching the MySQL database. Let's see what here. Nothing too interesting in the users and groups. Let's see. So, interesting enough, root logged in today. Not too long ago, actually. Like, this is us, reader. We logged in Saturday, July 11th at this time right here. And then root logged in slightly after us, which is awfully suspicious, I think. I'm on VIP, so I don't think it is quite unlikely that other HackTheBox players are here, but I don't know. This is still suspicious to me for a HackTheBox machine. So we know that root definitely logs on, which could be abused later on if we find some interesting vulnerability. Nothing here with MySQL, nothing with Apache, it's all standard. Nothing in FTP, that's odd. FTP wasn't even running, so we can just ignore that. Permit root login, yes. Oh, that's interesting. So apparently we can go and log in remotely as root through SSH. So, interesting. Obviously, private keys, we're able to read them. And keep going down. We don't care about the cloud stuff right there. Here's some SUID binaries. I don't see any SUID binaries we can abuse right here. Even though they're marked in red, they're not really exploitable in this context. Same for sgid, so group IDs. Group IDs is root, not interested there. Got some Linux capabilities right here. So we might be able to capture and sniff network traffic. That's interesting. Keep going down. And here's some interesting files that might be worth reading. I'm not too interested in this stuff right here. However, we have a writable log file. So, access.log that we saw earlier, which could be vulnerable to this logrotten stuff. So we should definitely check this out. So maybe let's copy this right here, writable blah. Go to vim, call this logrotten. And yeah, so keep going down, readable bash history, bash profiles. We get some more stuff right here. Hidden files doesn't look too interesting. We do see some app armor stuff though, which might be problematic. So keep going down, and don't see anything here. Yeah. So first things first, let's try the easiest task on our list. Go find the MySQL database, check for password reuse. So let's just get that off our list because it's quick and dirty. So let's go to var www.html. That's the standard web directory for Apache on modern modern Ubuntu distros. And let's go and cat db.php. That looks pretty promising. Cool. So book admin, I hate book reading book. We could also recursive grep for this right here, MySQL I connect, so grep r, MySQL I connect star. And we don't see any other strings that might indicate usernames or passwords right here. So we could do recursive grep for password, maybe do some regex right here. So password pwd pass w star. So this will find all password stuff in here. There's not really much too interesting right here. So no password right there. Anyways, we might find something in the database that we have access to. So let's go MySQL u book admin. Password is I hate book reading, and the database is book, but we're just going to log in like this. So let's see what databases we have access to. So show databases. It looks like we do have access to the MySQL database, so we can go select star from mysql.user, and we get a bunch of gunk right here. So let's do the /g, so format it a bit better. So we have, what I care about is the password. So the password field differs per MySQL installation. So in this case, it's authentication string. So we're gonna go select user authentication string from MySQL user, semicolon. So we have root, which doesn't have one, MySQL session, not a valid password that can be used here, neither this, wmate, we don't care, and book admin. So we already know the password for book admin because it was plain text. So let's go ahead and see if we can go and go into the book database. So go to use book, show tables, and let's go check out the users, see if we can get some password hashes right there. So select star from users, and conveniently enough, they're not even hashed. So let's try taking the super secure pass, Control Shift C, and try using this as the root user. We might as well enumerate everything else while we're at it. So select star from collections, nothing there. Select star from feedback, nothing there. Select star from messages. Surprisingly, there's nothing there either. So let's exit and make sure we have this super secure pass in our buffer. Let's try to become root with this. So su root, password is that, and it didn't work. Okay, so I'm still going to keep note of this. So I'll just copy this and go to our notes back here. Maybe let's call this creds.txt, set paste, so we can paste this. So we'll just call this web app. And have the super secure pass right here, should have said Z. Cool. All right. So we've taken note of the credentials. We've taken everything from the database, and all right. So next thing on our list is, let's go to notes, the suspicious timer, because that's also easy to check. Actually, no, suspicious file, root reset.sh. Let's see if we can't list that. So ls-l, blah, permission denied. Didn't work. All right, so let's try finding this. See if we can check this off our list. So find from root, name is this, direct all error, all permission there is to dev null. Maybe use the ls flag as well. Cool, so let's take a look at this. And this gives us some context. It says a backup is executed every minute. So on bootsec, 1 minute, unit is book.service. So let's see if we can't find the book.service. This will give us more context into how this actually works. So run the find command again. Here are the minute characters. Find name book.service, ls2 dev null. Take a look at this guy right here. And this is a backup of my Apache website logs. Type simple, exec start root log.sh. So maybe we can access this file. Permission denied. Okay. All right, so at this point, we've crossed out every item on our list. So let's see if, we did notice cron jobs were running like every 35 seconds. And more specifically, this book.timer, or sorry, the book.service will execute root log sh, and book.timer will fire as well, and that should probably trigger the shell script reset.sh. And since this is a shell script, underneath the hood it's going to be executing commands, and we can actually go ahead and monitor that with a tool that I like to use called pspy. So how about we go do that right now? Let's go snoop on what root is doing. So I'm going to go to dev shm, shared memory, and go ahead and create, another tab, because we're going to go download this tool. So cd tools pspy. If you don't have this tool, you can go on GitHub and go look for like pspy. Go here. Oh, I spelled that wrong. Here we go. Yeah, so you want to go ahead and download this right here. You can probably just go to... This is the new GitHub interface. Still kind of get used to it. They should have releases somewhere, but either way, you can just go ahead and download it or clone it. Okay, so let's go back to our Kali machine. I have this binary here, so you can go python 3-m http.server. Apparently it's already in use. We don't need this anymore, so let's exit there. And go ahead and go wget http, your IP address, go by port 8000, pspy 64. Go download it. There it is. Control C, we don't need this anymore. Get rid of this window. Make it executable, chmod x. And let's go ahead and spy on root. So let's give it a run. And keep that running in the background. Let's create a new session right here. And let's SSH back into the box. So interestingly enough, we are seeing quite a bit of, well, we saw some action there because I just logged in, but might as well check the output, see what, if anything weird is going on here. So interestingly enough, logrotate is being executed. More specifically, logrotate is being executed on a custom configuration file under the root directory with the /force flag. So what does this mean? Well, let's go man log rotate. So if we check the man page, we'll say that normally log rotate is run as a daily cron job. It will not modify a log more than once in a day, unless the criterion for that log is based on the log size. So this is actually a key detail in this exploit. So it's based on the fact that the log is based on the log size, and log rotate is being run more than once each day, or unless the -f or force option is used. So let's see. Let me move this right up here. It's out of the way. So we go to backups, ls-lh. These files are very old, they're from January, it's July right now. And they haven't, clearly the size hasn't changed, but what happens if we went ahead and changed the size of access.log? So let's try going something like echo rocket to access.log. Maybe go here, and ls-l, and suddenly access.log got copied into access.log.1. So if we cat this, it says rocket, and access.log got cleared back to 0. So clearly this file here got copied into this and moved the contents here. It's just pretty much the log got rotated. So log rotate went in action. And there is an issue with log rotate where if you, the user, have write access to the directory that's being log rotated, you're able to exploit a race condition where you actually go ahead and symlink this directory right here. So in this case, the directory is called backups. So this thing gets symlinked just before log rotate is able to copy this file into this one right here. So basically, backups will end up getting symlinked to some sensitive directory like the etc bash completion.d directory, and then it's going to take the access log and then copy it into here, basically. So then as soon as root logs in, we'll be executing code as root. So if you want to learn more on that exploit, I think Hacktricks has got you covered. So you can just look for logrotten, and actually even better than that, actually even better than Hacktricks is this blog post from HackerOne, where I think this guy here was the original author of the exploit that we're about to use. So yeah, I'll be linking this in the video description below. Anyhow, I think you should be able to get the proof of concept somewhere. Actually, yeah, you can get the proof of concept from here, logrotten. So just go ahead and clone this. And I think I already have it on my machine. So, go on the right screen, okay. So I'm going to go and create, I think my stuff is under tools as always. Go to logrotten, I've already cloned it. So I'm just gonna go copy the logrotten.c file to, I think it was like home, HTTP, write-ups, boxes, book, and that's fine. Let's go over here. Let's make a directory called privesc. And we'll move logrotten.c to privesc. Go to privesc, and we can go ahead and take a look at this file right here. move this down here. Okay. So this is how you use it. Again, like I said, it's prone to erase condition after renaming the log file. And we're basically going to go and resymlink this before logrotate can write to the directory. So what I tried is you can go and compile this file, and so we're going to spin up an HTTP server here. So Python 3-m http.server. And if we go ahead and we'll go to dev shm, and we'll go wget http 10.10.14.15 port 8000. We'll just call this logrotten.c. Go ahead and download this. Could go ahead and go gcc logrotten.c. Output file will be called logrotten. That worked. Interestingly enough, we can see our gcc getting compiled down here. Sorry, our source code getting compiled to an ls. We can go logrotten. So we can go ahead and run this. So I'm actually going to stop pspy right here for a second, because probably don't need it now that we have an idea of what's going on. And go back to do an ls on backups. So go to backups, and what we want to, the way how to use this is we can go logrotten, and we need a payload file. So the last time I tried this exploit, just for the sake of this video, try to keep it shorter. The example source code recommends you try to get a reverse shell. The reverse shell works, but it is also very short-lived. So in practice, it wouldn't be really that useful. So instead, I'm going to create a payload file that is going to go and try to create a backdoor user here. And to do that, I'm just going to call this payload file. So this is what's going to get written to the etc bash completion directory eventually. So we'll do something like, we're going to add a backdoor user to etc passwd. So just to make sure that our code gets executed, we can go ping c1 10.10 14 not 48 15. So we ping ourselves, and then we can go ahead and dump our etc passwd file. So cat, actually we're going to do head and head1 etc passwd. So we're going to take this thing right here, which is the first entry in a passwd file, and we're actually going to create a backdoor user by appending this to /etc passwd. And of course, if you have the x, that means the hash is, well, there's an actual hash in the etc shadow file, but to keep it easier, we're just gonna go open ssl passwd, enter a password of our choice, verify it, and we can just use this instead. So this is the password hash. So instead of calling ourselves root, we're gonna call ourselves rocket. So rocket is a backdoor root user. Notice that our user ID will be 0 and our group ID will also be 0. So keep that. And we're going to want to download this as well. So Python 3-m http.server and wget, actually do it in this devshim window. So wget http 10.10.14.15 port 8000. We'll get a payload file. Cool. So that's good. We can probably close this right here for more room. Cat payload file looks good to me. Okay. So the way how to use this is you run logrotten and then -d because we want to debug, and -p for a payload file, which is payload file. And ultimately we want to go target our, the file that we're going to write to, which is in turn going to get copied to this same directory right here. But before it's able to copy it to this directory, our logrotten is going to symlink this to the etc bash completion.d, so that this thing is going to get written as this to etc bash completion.d. So let's go ahead and go pwd. So this is our absolute path. So this, and we want access.log. Cool. So it's waiting for it to rotate. Let's go ahead and rotate it. Let's do the trigger so we can cat our, well, we can just go echo anything, just say rocket to access.log. I should trigger it, so when we do an ls-l, we should have a 3 soon. There it is, done. Okay, cool. So now if we go ahead and check our, actually, I want to do a sudo tcp dump -i ton 0 mycmp, because our payload file was ping. So let's see if that actually got written to etc bash completion.d, and looks like it did. So I also put debug, so because the program by default checks for this right here, and we got pinged. So our code got executed. We should have our backdoor user. So cat etc passwd. Look, we do have the rocket user, and if we do su rocket with our password of our choice, we are now root. So go to root /l /l. We can see that there's a flag right there. So that is the box. If you made up until this point, I can't thank you enough for your time, and if you enjoyed the video, please hit the like, comment, and subscribe buttons. It really helps out the channel. But more importantly, I hope that you learned something new that you can bring back to your organization. That said, I hope to see you in the next video.